Welcome to the Thinking Abyss podcast, a philosophical journey through consciousness, reality, and the phenomena that challenge our understanding of existence. From ancient wisdom to cutting-edge theories, we explore where philosophy meets science and curiosity leads to the edge of the unknown.
Welcome to the Deep Dive. We dig through complex research, pull out the gems, and we'll basically hand them right over to you.
And today, we're on a pretty big mission, actually.
We really are. We're trying to look inside the mind to answer this, incredibly old question. Where do truly original ideas come from?
Yeah, for ages, people just called it inspiration, right? Like some kind of divine spark or something hitting you from the outside.
A lightning bolt.
Exactly.
Yeah.
But now, thanks to things like brain imaging, fMRI, and so on, we understand it's not mystical at all. It's neuroscience. Pure, complex, sometimes a bit messy neuroscience.
And we're going to unpack that in neuroscience today.
Mm-hmm.
Starting with something I think everyone experiences, that classic paradox of the shower insight.
Mm-hmm.
You know, you've been wrestling with a problem all day, maybe a tough business strategy or a coding bug or, a plot hole in a story you're writing.
Right, you're focused, you're trying hard at your desk.
You just hit a wall.
Yeah.
Nothing. So you step away, maybe hop in the shower or walk the dog, whatever, and boom, the solution just appears, like fully formed.
That's the mystery, isn't it? The lightning strike. The idea feels totally out of the blue, like, where did my brain even find that? But at the exact same time, it feels completely obvious.
So obvious. Like it was sitting there the whole time just waiting for you to, stop trying so hard so it could pop up.
Exactly. And that feeling, that sudden breakthrough, that's really the core question neuroscientists are digging into.
How does this, 3-pound lump of tissue in our heads running on barely any power?
Like a dim light bulb, yeah.
How does it generate ideas, solutions, images that literally didn't exist anywhere just moments before?
And this whole line of research, it just completely overturns that old myth of inspiration, doesn't it?
Absolutely. The idea that creativity was like whispered by the muses or it was some rare talent only given to a few geniuses.
Right. The idea that if you weren't one of the chosen few, well, tough luck.
Our sources today, they just blow that out of the water. It's scientifically, just wrong.
Totally outdated. The modern view is that creativity isn't some single magic button or a special gift for artists. It's this really intricate, dynamic dance between specific brain networks.
Networks that everyone has.
Everyone has them. The difference often comes down to how well these networks talk to each other, how coordinated they are, and a lot of this happens unconsciously.
So our mission today is really to give you, the listener, kind of shortcut to understanding that conversation inside your own head.
Yeah, the 3 key networks, the chemical messengers that help them out, and importantly, how you can maybe tweak things in your life to encourage more of those aha moments.
Okay, so let's dive right in. Section 1, the creative brain, thinking of it as a symphony of networks. And really, we couldn't even be having this chat without some major tech advances, right? Late 20th century stuff.
Oh, absolutely. Things like fMRI, functional magnetic resonance imaging.
Yeah.
That was the game changer. It let scientists actually watch the living brain in action in real time.
See what lights up when someone's, say, trying to solve a creative puzzle.
Exactly. Before that, it was all indirect evidence, educated guesses. Now we could actually see it happening.
And the first big surprise was there wasn't one single spot that lit up labeled Creativity Center.
No genius lobe, unfortunately. What they found instead was that creativity doesn't come from one place, but from the interaction between multiple different brain networks. They fire together, or in sequence, dynamically.
Like teamwork inside the skull.
Yeah, I kind of like the analogy of a jazz ensemble. You've got different players, each with their own instrument, their own style, and they're improvising together. They're blending structure and spontaneity to create something totally new, something none of them could have done on their own.
That's a great way to put it. It really captures that balance.
Yeah.
It's not just one solo genius. It's this complex, coordinated thing. So our sources point to 3 main players in this neural band.
Right. We can think of them by their main jobs: the executive attention network, the default mode network, and the Salience Network. Or maybe the director, the dreamer, and the talent scout.
Okay, let's start with the director. Network 1, the executive attention network, or EAN.
Okay, so the EAN, its home base is mostly in the prefrontal cortex, right at the front of your brain. And its job is all about focused, effortful control, like cognitive control.
So when I'm really concentrating, planning something step by step, trying to hold information in my head.
That's the EAN running the show. solving a math problem, following instructions, focusing on one speaker in a noisy room. It's all about convergent thinking, narrowing down possibilities to find the single best logical answer.
So it's pretty essential for, well, functioning in the world. It's the part that gets stuff done, keeps you on track.
Oh, it's absolutely crucial, especially for refining ideas, checking them, implementing them. Without the EAN, those brilliant flashes would just fizzle out. You wouldn't finish anything.
But there's a catch, right? The neuroscience shows a downside.
Yeah, here's the really critical finding for creativity. Too much EAN control, being too focused, can actually shut down originality. It can inhibit it.
Why would being focused stop you from finding a solution?
Well, if the EAN is always in charge, it imposes really strict rules and relies heavily on known patterns, things that worked before. It's like an overeager editor.
Okay.
It filters out weird or seemingly illogical connections before they even get a chance to form properly. The brain likes efficiency, right? So the EAN pushes you toward the tried and true, the conventional path.
So to find something truly new, you actually need the director to relax a bit, take a break.
You need to loosen its grip, exactly. Which explains why just staring harder at the problem often doesn't work. You're just strengthening that EAN dominance, blocking the source of novelty.
Which brings us perfectly to network 2, the default mode network, the DMN, the dreamer.
The DMN. This one's got a bit of a romantic backstory in neuroscience. It's not just in one spot. It's distributed parts in the medial prefrontal cortex, posterior cingulate, angular gyrus. Areas involved in thinking about yourself, remembering your past, integrating information.
And its discovery was unexpected.
Completely accidental, yeah. In early brain scans, researchers needed people to do tasks, but they also needed baseline rest periods.
Right, something to compare the task activity against.
Exactly. So they'd tell people, just lie still, let your mind wander. And they saw these specific brain regions become highly active during this rest.
More active than during simple tasks sometimes.
Often, yes. Initially, they kind of dismissed it, called it neural noise, or maybe the brain's screensaver just ticking over.
The opposite of doing useful work.
Seemed like it. But then it turned out this idle network is actually one of the most energy-hungry networks in the brain. It uses a lot of resources, even when you're supposedly doing nothing.
Wow. So what is it doing?
Its real job is incredibly important. Things like consolidating memories, planning for the future, like mentally simulating scenarios, and crucially for creativity, associative thinking, mind wandering. When your mind drifts, the DMN is hard at work, rummaging through this massive library of everything you know and had experienced.
But it's not looking for the right answer like the EAN.
No, it's looking for unexpected links. Novel patterns, weird connections between seemingly unrelated things.
So if the EAN is convergent thinking, narrowing down the DMN is pure divergent thinking, throwing the net really wide.
Absolutely. And studies show it clearly. Higher DMN activity correlates with generating more creative answers on tasks. Like, think of unusual uses for a brick.
Right.
It explores connections the conscious, logical EAN would probably just dismiss immediately as silly or irrelevant.
And that's why the shower moment happens. The EAN finally takes a backseat.
His grip loosens.
And the dreamer network gets the freedom to explore these weird long-distance connections.
Precisely.
Okay, so we have the focus director, EAN, the wandering dreamer, DMN. But you could generate a million weird ideas. How does the brain know when one of those DMN connections is actually promising? Useful. We need another filter, but not the rigid EAN one.
That brings us to network 3, the Salience Network, or SN, the talent scout.
The talent scout? I like that.
The SN is really the key to that aha feeling, the insight itself. It's anchored in brain regions like the anterior insula and the dorsal anterior cingulate cortex. And its job is basically constant monitoring.
Monitoring what?
It's listening to all the information streams from the outside world through your senses and from your internal world, including the stuff bubbling up from the DMN. And it identifies what's important, what's salient, what deserves to grab your conscious attention.
So it's like the brain's priority manager.
It's more than just prioritizing. It acts as this crucial bridge, specifically between the DMN and the EAN. Imagine the DMN churning out thousands of potential connections, many of them just noise, some really strange. The SN is kind of quietly watching this stream, evaluating these background connections. It's like a scout watching hundreds of young players.
Looking for that one future star.
Exactly. And when the SN detects a pattern, a connection from the DMN that seems particularly novel, useful, or promising something developed below the threshold of your awareness, it sends up a flag. It signals the EAN.
It basically says, hey, director, look at this.
Pretty much. And that signal, that sudden shift of attention to this previously unconscious idea, that is the subjective experience of the aha moment. The SN promotes the DMN's backstage work onto the main stage of conscious thought.
Wow. So the breakthrough isn't random luck. It's the talent scout spotting potential in the dreamer's exploration.
That's the model, yeah. And the research suggests that the smoother and more efficient the communication between these three networks, the EAN, DMN, and SN, the more readily insights can emerge. Higher creative output seems linked to better coordination in this neural ensemble.
Okay, that makes the individual players clear.
Yeah.
Now let's look at how they play together in section 2. The creative process cycle and the thing you called the effort paradox.
Yeah.
If the networks are the musicians, you said the cycle is like the sheet music they follow.
Sort of, yeah. It's a predictable sequence, though maybe less rigid than sheet music. The real power isn't just having these networks, it's how they coordinate, how they hand off to each other.
So walk us through the typical cycle.
Okay, it generally starts with phase 1, preparation. This is where the EAN is dominant. High focus, intense effort.
All right, the conscious work. Researching, defining the problem, brainstorming initial ideas, trying things out.
Exactly. You're actively engaging, gathering information. This is necessary. You need to immerse yourself in the problem space. This is the grinding part.
The banging your head against the wall part we talked about earlier.
That's often part of it, yeah. But then ideally, once the EAN has sort of saturated itself with information, maybe even gotten a bit fatigued, the brain shifts gears.
Into phase 2.
Into phase 2. Incubation. Yeah. This is key. EAN activity drops significantly. The director steps back, and the DMN, the dreamer, takes over.
This is when you deliberately step away. Take that walk, sleep on it, do something unrelated.
Ideally, yes. You let the problem simmer. The DMN starts its broad associative search in the background, exploring those weird connections. Meanwhile, the SN, the talent scout, is still kind of monitoring, listening in the background for anything interesting.
Making that switch, consciously deciding to stop trying so hard, that feels like the hardest step for a lot of people, myself included.
It really is. Because our culture rewards visible effort, right? Stepping away feels like slacking off. But neuroscientifically, incubation is absolutely essential work. It's when the brain is restructuring the problem, exploring pathways the EAN wouldn't allow.
Okay, so you incubate, then what?
Then, hopefully, comes the magic moment. Phase 3, illumination. The breakthrough.
Yeah.
That's the SN detecting a promising connection forged by the DMN during incubation. It signals the EAN, pay attention. Your conscious mind snaps back to the problem, but now with this new insight seemingly appearing out of nowhere.
It feels sudden, but it was building unconsciously.
Exactly. And then that leads immediately into phase 4, verification.
The director comes back online.
Full force. The EAN takes the newly surfaced idea and puts it through its paces. Is it logical? Does it actually work? Can it be refined? How do we implement it? This is the critical reality check. Without verification, the DMN's brilliant idea might just remain a half-baked concept.
So preparation, EAN, incubation, DMN-SN, watch, illumination, SN signals EAN, verification, EAN. That cycle really explains that counterintuitive thing, the effort paradox.
It does. The paradox is that sometimes trying harder, putting in more focused EAN effort, actually makes you less likely to find a novel solution.
Because the EAN actively suppresses the DMN.
In a way, yes. They can be somewhat antagonistic. You need enough focused effort in the preparation phase to really understand the problem and feed your brain the raw material.
You can't skip the homework.
No. But then for genuine novelty, you need that period of relaxed conscious control during incubation to let the DMN do its thing without the EAN constantly judging and filtering based on old rules.
Finding that sweet spot between focused work and letting go.
That seems to be the key. Focused effort and divergent exploration are, at least temporarily, opposing states in the brain.
So incubation isn't laziness. It's literally optimizing your brain's networks for discovery. It's required downtime.
Mandatory neurobiological optimization. I like that. And remember, the DMN's search during incubation is only as good as the library it's searching through.
Right, the raw materials. Creativity isn't magic. It's recombining things you already know or have experienced in new ways.
Exactly. It's building with existing bricks, just maybe in a surprising new structure.
So what makes one person's internal library, their memories and experiences, a richer source for the DMN than someone else's?
The research points to a few key things. First, and maybe most obviously, is diversity.
Diverse experiences.
Yeah. The more varied your life experiences, different jobs, skills, cultures you've encountered, subjects you've learned about, the richer and more varied the set of bricks the DMN has to play with.
Someone who studied both art history and computer science has more potential connections to make than someone who only knows one field deeply.
Precisely. More ingredients mean more potential for unexpected combinations. The second factor is contextual richness of the memories.
Meaning how vividly you remember something.
Sort of. It's about how much associated information is stored with the memory. Was it linked to strong emotions? Multiple senses. Did you learn it through abstract study or through direct embodied experience?
Oh, okay. So a memory that's tied into more neural networks is easier for the DMN to grab onto.
It seems so. Richly encoded memories are more accessible and more flexible for the DMN's associative searches. They have more handles to be grabbed by.
That makes intuitive sense. And the third characteristic, you mentioned something fascinating earlier.
Right. This one is really cool. Ambiguity. Or maybe imperfection.
Imperfect memories are better. How?
Well, some research suggests that memories that are a bit fuzzy, partially forgotten, or slightly degraded over time might actually be more useful for creativity than crystal clear ones.
That seems totally backward.
It does. But think about it. When a memory is incomplete, the brain doesn't just leave a blank. It tries to reconstruct it, to fill in the gaps.
Yeah.
And that reconstruction process isn't always perfectly accurate. The brain might pull in related concepts, make inferences, essentially introduce new elements while trying to rebuild the old memory.
So the bugs in the memory system, the forgetting, the fuzziness become features, opportunities for novelty to sneak in.
That seems to be the idea. The brain is kind of improvising based on the fragments, and that improvisation can lead to genuinely new combinations. It's using the slight degradation of the past to construct a novel future. Powerful stuff.
Wow, okay, so we've got the networks, the cycle they run through, the importance of memory. But what's actually driving the shifts between these states? What's modulating the activity? That takes us to section 3, the neurotransmitter orchestra.
Right. If the networks are the structure, the neurotransmitters are like the chemicals that adjust the volume, the tempo, the mood of the orchestra. They influence how the networks operate and communicate.
And the first one we have to talk about is probably the most famous, dopamine, the reward chemical.
Absolutely central. Dopamine plays a huge role in creativity. It does a couple of key things. First, it provides that feeling of pleasure and reward associated with the aha moment.
That rush you get when you finally crack it.
Exactly. That reinforces the whole creative seeking behavior. It makes you want to do it again. But it also seems critical for cognitive flexibility, particularly in the prefrontal cortex.
Helping you switch sets, think outside the box.
Yes, making it easier to explore different approaches, which is vital for letting the DMN roam effectively.
So what does the dopamine level look like across that 4-phase cycle we talked about?
It's not just high all the time. The pattern is really interesting. During preparation, phase 1, and especially incubation, phase 2, dopamine levels might actually be relatively lower.
Lower? Why would less reward chemical help?
Well, the theory is that slightly lower dopamine might help break habitual thought patterns. It reduces the brain's reliance on the usual, most rewarding conventional pathways. It kind of quiets the system down to allow for more divergent exploration.
Okay, so a dip allows for the surge.
But then, when illumination happens, phase 3, when the SN flags that great idea from the DMN, bam, there's a big surge in dopamine.
The reward hits.
And that surge does more than just feel good. It acts like a chemical save button. It strengthens the new neural connections associated with that breakthrough idea, making it more likely to stick, to be remembered and used.
It locks in the novel pathway. That explains why insights feel so significant, almost addictive sometimes.
It definitely contributes to that drive. Which leads us nicely to the next chemical player, norepinephrine, sometimes called noradrenaline. This is the brain's main arousal chemical.
So alertness, focus, but also stress, fight or flight.
Exactly. It's complicated. Moderate levels of norepinephrine are good. They help you maintain focus and vigilance, which is useful during the preparation phase and the verification phase. You need that alertness.
But the stress part, that's bad for creativity.
That's the critical point. High levels of norepinephrine, the kind you get when you're significantly stressed or anxious, are really detrimental to creativity. High norepinephrine forces the brain into a narrow survival-focused mode. Your EAN goes into overdrive, focusing only on the immediate perceived threat or problem. Cognitive flexibility plummets.
You get tunnel vision, basically.
Mental tunnel vision, yes. The DMN's broad exploratory searching gets shut down. Your brain thinks, no time for weird ideas now, there might be a tiger. So creativity really needs a relatively relaxed state. Low to moderate norepinephrine allows the DMN the freedom it needs.
That's a very direct chemical explanation for why trying to force creative solutions under intense pressure usually backfires spectacularly.
It really is. Okay, next up, GABA, gamma-aminobutyric acid. This is the brain's primary inhibitory neurotransmitter. It calms things down.
Wait, so we need dopamine surges and moderate norepinephrine, but we also need something that slows the brain down. How does that help creativity?
It seems counterintuitive, but GABA plays a crucial role in quieting the noise, particularly the internal critic. It helps reduce cognitive inhibitions.
Inhibitions, like judging ideas too quickly.
Exactly. Remember how the EAN can be overly critical and filter out unconventional ideas? GABA helps to dampen that excessive filtering. It allows more unusual, seemingly strange associations from the DMN to actually reach the SN for consideration.
So GABA turns down the volume on the EAN's judgment, letting the weirder ideas get a hearing.
That's a good way to put it. Some research suggests that people who are naturally more creative might have systems where GABA is more effective at reducing this cognitive inhibition. They're just less likely to shoot down a novel idea internally before it even surfaces.
So you need to inhibit the internal inhibitor sometimes. That's wonderfully complex.
It really is a delicate balance, and we should probably briefly mention acetylcholine too. It's heavily involved in attention and learning.
How does it fit into the creativity picture?
It seems to play a key role in modulating the shifts between different attentional states, like shifting from the focused EAN state needed for preparation to the more diffuse open awareness state needed for DMN activity during incubation and back again. It helps conduct the smooth transitions within the cycle.
So it's like the stage manager ensuring the right network takes the lead at the right time.
Sort of, yeah. It facilitates the flexibility needed to move through the creative process effectively. It's truly this intricate chemical orchestra playing alongside the network ensemble.
This is getting incredibly detailed. I love it. Okay, let's push a bit deeper in section 4. Looking at some nuance and maybe inevitably the dark side of the creative mind. You mentioned we need to revisit the DMN, the default mode network, because just calling it default doesn't really capture it.
Not at all. As we touched on, it's incredibly energy intensive. The brain isn't just idling, it's doing serious work during that rest. Its structure is complex. You've got the medial prefrontal cortex constantly relating things to the self, the posterior cingulate cortex pulling up autobiographical memories, the angular gyrus integrating different types of information.
It's constantly simulating, remembering, connecting. Less like a screensaver, more like a background simulation engine.
That's a much better analogy. And its connectivity is really its superpower for creativity. Unlike highly specialized networks that mostly talk within their own region, the DMN forms these extensive long-range connections across widely separated parts of the brain.
So it's physically built to link disparate areas.
Exactly. That's what allows it to synthesize things like, a memory from childhood, a technical detail from work, and the feeling evoked by a piece of music into one novel concept. It bridges these huge conceptual gaps because it has the wiring to do so.
It's not just finding neighbors. It's making connections across the whole city of the brain.
Well put. And importantly, it's not just random wandering either. Research suggests the DMN's exploration isn't chaotic. It follows predictable associative pathways, kind of like grooves worn into your mental landscape based on your past experiences and knowledge.
So it's a guided exploration, even if it feels random to us.
Seems so. It's exploring the underlying structure of your own unique knowledge base, which is probably why when an insight emerges, it often feels strangely familiar or deeply relevant, even though you weren't consciously looking for it.
The aha moment isn't magic. It's an emergent property of that deep structural exploration. Okay, let's shift slightly. We often picture creativity as this solitary thing. The lone inventor in the garage, the writer locked away in a cabin.
The stereotype, yeah.
But the sources we looked at suggest creativity is actually deeply social, even when you're alone. How does that work?
It's fascinating. Even during individual creative tasks, brain regions associated with the social brain areas, like temporal parietal junction, which helps us understand others' perspectives, their mental states, theory of mind, these areas are active.
But why? If I'm just trying to solve a math problem by myself, why is the part of my brain that thinks about other people lighting up?
Well, think about what makes an idea truly impactful or meaningful. Often it's because it solves a human problem or communicates something effectively to other humans or fits within a social or cultural context.
Oh.
The social brain seems to be involved in helping us implicitly consider these things. How might others react to this idea? Does this solution make sense from another perspective? It helps shape the DMN's exploration towards generating ideas that are not just novel, but potentially relevant and useful in a broader human context.
So empathy, understanding social dynamics, it's almost baked into the creative process itself, even for seemingly non-social tasks.
It appears so, and there's a correlation. Studies show people who score higher on measures of empathy and social understanding often tend to be more creative, particularly in versatile ways. Individual insight is one thing, but making it land, making it work in the world often requires that social tuning. Collective creativity, building on ideas together, leverages this even more explicitly.
That really undermines the romantic lone geniuses myth even further. Okay, now we need to confront the difficult part. The trade-offs, the dark side of creativity. The same brain setups that foster originality can also cause problems, right?
Yes, and it's crucial we acknowledge this. It's not just anecdote. There's neurobiological evidence. Let's start back with the DMN.
The dreamer network.
While it's essential for that associative wandering, if the DMN becomes overactive or poorly regulated, if it just keeps spinning without productive engagement with the EAN or the outside world, it's strongly linked to problems like rumination.
Going over and over the same negative thoughts.
Exactly. Getting stuck in loops of negative self-focus, worry about the past, anxiety about the future. This might be one reason why statistically, highly creative populations sometimes show higher rates of mood disorders like anxiety and depression. Their core creative engine, the DMN, is perhaps more prone to getting stuck in these unproductive, painful cycles, if not well managed.
The dreamer becomes a tormentor.
It can feel that way. Then there's the issue we discussed with GABA and reduced inhibition.
Letting the weird ideas through.
Yes, that lower cognitive inhibition is great for brainstorming, for divergent thinking. But the flip side is that it can make it genuinely difficult to filter out irrelevant information from the environment.
Trouble focusing. Getting easily distracted.
Very much so. Difficulty sustaining attention on necessary but perhaps less stimulating tasks. Managing sensory input can be overwhelming. The same mental flexibility that allows novel connections can make conforming to structured, predictable environments feel incredibly taxing.
It's like the brain is wired to resist boxes, which is great for art, but maybe not great for filling out tax forms.
That's a relatable way to put it. And finally, let's circle back to dopamine.
The reward chemical.
That intense pleasure spike from an insight, that aha moment dopamine rush, can be very reinforcing. For some, it might create a drive for constant novelty seeking, a kind of creative addiction.
Always chasing the next breakthrough.
Yeah. The potential problem there is difficulty with phase 4, verification and implementation. The person might get hooked on the excitement of generating new ideas, phase 3 high, but struggle with the often less glamorous, sustained effort needed to actually finish projects and bring those ideas to fruition. They're already chasing the next dopamine hit from a new idea.
This really grounds those stereotypes, the brilliant but scattered artist, the mad scientist, in actual neurochemical processes. These aren't just personality quirks. They can be real trade-offs wired into the system. Okay, so understanding the networks, the cycle, the chemicals, even the potential downsides. What does this mean for us? How can we actually use this knowledge? Let's get practical in Section 5, cultivating the creative brain. The big takeaway seems to be good news, right? Creativity isn't fixed.
That's the most empowering message from all this research, I think. The brain is plastic. These networks and their coordination can be strengthened and improved. Creativity is a skill you can develop.
So, if the goal is better coordination between the director, the dreamer, and the talent scout, EAN, DMN, SNN, what are the proven ways to do that?
Well, one of the most consistently supported practices is meditation, specifically a type called open monitoring meditation, or OMM.
How is that different from just focusing on your breath?
Focused attention meditation primarily trains the EAN's sustaining focus. OMM is different. You cultivate a state of non-judgmental awareness of whatever comes into your consciousness, thoughts, feelings, sensations, without latching on to any particular thing. You just observe it arise and pass away.
That sounds challenging.
Yeah.
But how does it help creativity?
It seems to train the whole system beautifully. It strengthens DMN connectivity, allowing that free flow of thoughts. But crucially, it also strengthens the SN's ability to notice these thoughts without the EAN immediately reacting or judging. You're practicing observing the stream, identifying what's interesting, but not getting swept away or shutting it down.
You're basically practicing the incubation and illumination phases internally.
That's a great way to think about it, yeah.
Yes.
You're enhancing that smooth transition and awareness. Another big one, physical exercise, especially aerobic exercise.
Running, swimming,
Exactly. Exercise does amazing things for the brain. First, it boosts BDNF, brain-derived neurotrophic factor. People call it miracle grow for the brain.
because it helps new connections grow.
Yes, it promotes neurogenesis and synaptic plasticity, making the brain more adaptable and better at learning and forming new pathways. Plus, exercise is a fantastic chemical optimizer. It helps regulate neurotransmitters, crucially reducing those creativity-killing high levels of stress hormones like norepinephrine and cortisol.
Creating that relaxed yet alert state ideal for the DMN.
Precisely. It's really no wonder so many people report getting their best ideas during or right after a good workout. The brain chemistry is just primed for it.
And we absolutely have to talk about sleep.
Oh, non-negotiable for creativity. Sleep isn't just passive downtime, it's active, essential brain maintenance and optimization, particularly REM sleep.
The dreaming stage.
Yes. During REM, the brain seems to be actively consolidating memories, but also specifically strengthening weaker, more distant associations, exactly the kind of long-range connections the DMN makes for novel ideas.
So it's literally finding and reinforcing those unusual links while you sleep.
It seems to be pruning irrelevant connections and strengthening the potentially interesting weak ones. It's running creative algorithms offline. People often wake up with solutions to problems they were stuck on, and this REM activity is likely a big reason why.
Okay, meditation, exercise, sleep, those are things we do with our bodies and minds. What about our environment? Can we shape our physical space to help?
The evidence suggests yes, though maybe subtly. Some studies find things like higher ceilings, exposure to natural light, and even just having views of nature can enhance creative thinking.
Higher ceilings. Really, why?
The hypothesis is that a sense of physical spaciousness might translate to a feeling of psychological spaciousness, reducing perceived constraints and making more abstract, expansive thinking feel easier.
Thinking bigger in a bigger space. Interesting.
It's like giving your DMN more room to roam, metaphorically. And another environmental factor, noise. We often assume silence is best for thinking.
But maybe not for creative thinking.
Exactly. Research suggests that moderate levels of ambient background noise, think the buzz of a coffee shop, around 70 decibels maybe, can actually improve performance on creative tasks compared to silence.
How on earth does noise help?
The theory is that moderate noise introduces just enough distraction to slightly impair the EAN's super-focused grip. It makes sharp focus a bit harder, which paradoxically forces the brain to rely more on the broader, more associative processing style of the DMN.
Huh. So the coffee shop stereotype has a neurobiological basis. It slightly disrupts your focus, which is good for insight.
It seems that way. It forces a slight loss of that tight EAN control, which is exactly what you need sometimes. And this all loops back to the crucial idea of valuing unproductive time.
Letting your mind wander, daydreaming.
Yes. Neuroscience confirms these aren't signs of laziness or procrastination when done strategically. They are essential acts of creative maintenance. You are deliberately quieting the EAN, allowing the DMN to do its consolidation, association, and optimization work, preparing the ground for the next insight.
We need to schedule downtime not as a luxury, but as an investment in future breakthroughs.
Couldn't have said it better myself. And finally, we should just briefly acknowledge that there are individual differences. Not everyone's networks are wired exactly the same or communicate with the same efficiency.
Some people might have naturally stronger connections between DMN and EAN, maybe mediated by a more effective SN.
That's likely part of it, leading to smoother transitions and maybe more frequent insights for some. And things change across the lifespan, too.
We talked about kids being divergent thinking machines.
Right. Early childhood is peak DMN exploration, high plasticity, low inhibition. Then structured schooling often heavily emphasizes EAN development, convergent thinking, the right answer, which can temporarily dampen creative output for some.
Training the director, sometimes at the expense of the dreamer.
But it's not lost. Adolescence involves huge brain reorganization, offering new chances for integration. And in adulthood, while some raw divergent thinking might decrease, the accumulation of knowledge and experience provides a much richer library for the DMN to draw upon. Plus, better emotional regulation and EAN development means adults can be much better at the verification and implementation phases.
So creativity isn't just a young person's game, mature creatives leverage deep knowledge and refined control.
Absolutely. Many people hit their creative peaks later in life, especially in fields requiring deep expertise, precisely because they have both the vast library and the executive skills to shape the insights into something real.
Okay, we have really covered a lot of ground here. The brain's creative networks, the process, the chemicals, the nuances, and how to cultivate it. Let's try to bring it all home.
Yeah, I think the core message, the big takeaway, is that creativity isn't some mystical force. It's a fundamental, universal capacity of the human brain. It emerges from this incredible interplay between the focused director, EAN, the associative dreamer, DMN, and the watchful talent scout, SN.
And it requires this rhythm, deliberate effort, then deliberate relaxation, preparation, then incubation. It's not just about trying harder.
Not at all. And it's all supported and modulated by this complex neurochemistry: dopamine for reward and flexibility, norepinephrine for arousal balance, GABA for quieting inhibition.
It really changes how you think about your own mind, doesn't it? So much of the important work, the actual generation of new possibilities, is happening beneath the surface, outside of our conscious awareness. We're constantly constructing meaning, even when we just feel like we're zoning out.
We really are, and it powerfully underscores the need for diversity in our lives. If creativity is about making novel connections, then the more diverse our inputs, the experiences we seek out, the people we talk to, the knowledge we gain, the richer the palette the DMN has to work with, and the more potential for truly original output.
So that leads us to our final thought, something for you, our listeners, to really chew on after this deep dive.
If we accept that the old myth of the solitary, isolated genius is, well, mostly a myth.
And if our brains are actually wired for social cognition, even during individual creative thought, suggesting that collective creativity and considering others' perspectives is fundamental.
Then how should that change how you think about structuring your own life, your work routines, your learning habits, even your company culture or educational systems? How can you intentionally design things to better foster collaboration, to encourage that sharing of diverse ideas, and to optimize that crucial dance between individual DMN dreaming and collective EAN verification?
Think about the spaces you work in, the noise levels, the value you place on downtime, and how intentionally you seek out different perspectives before your next big project.
Yeah.
Really something to consider.
Definitely. We hope this gave you some insights into your own creative process. We'll catch you on the next deep dive.